The speculation of the universe's beginning stage has for quite a long time been lauded as the essential clarification for the beginning stages of our universe. A hypothesis has driven forward over the very extensive passageway, giving a plan through which astrophysicists can get a handle on the incredible eccentricities known to man today. For a long time, this hypothesis has been refined and kept up with by a steadily developing social event of verification, making it a basis of stream cosmology. It offers an insightful story of how the universe started, by and large 13.7 quite a while back, beginning from a solitary, unimaginably hot and thick point that lengthy quickly. As per this hypothesis, the universe was created in an epic shoot that set the universe into movement, an idea that assists us with following the starting points of frameworks, stars, and, shockingly, the structure blocks of life itself. Be that as it may, the mystery loosens up when we attempt to figure out what, regardless, existed before the huge explosion. The occasions making ready to that second are canvassed in secret and are presently past the extent of human discernment. As of late, nonetheless, the story has been tried by new disclosures from the James Webb Space Telescope, JWST, which have touched off struggle and, without a doubt, even frenzy among specific cosmologists. These photos propose errors in the speculation of the universe's beginning stage, actuating experts to re-examine how they could decipher the universe's starting points. As we dive into the confirmation introduced by the JWST, we wind up close to the unsafe edge of possibly progressive disclosures, testing long-held convictions and clearing a path for additional potential outcomes in the area of cosmology. The energy encompassing the James Webb Space Telescope is unquestionable among standard scientists. This state-of-the-art telescope addresses an excellent jump forward in our capacity to notice the universe. Its significant level capacities, especially in catching infrared frequencies, are said to uncover portions of the universe that were recently stowed away from view. Research groups all over the planet have been anxiously anticipating their chance to use this strong instrument since it was announced functional. The JWST isn't simply one more telescope. This momentous gadget holds the possibility to respond to probably the main inquiries concerning the universe. The assumption was that this telescope would expand upon the achievements of its ancestor, the Hubble Space Telescope, giving even more clear and more nitty-gritty pictures of far-off frameworks, star groups, and perhaps the earliest snapshots of the universe. The disclosures came as a shock, as there were unanticipated disclosures that tested the theory of the universe's origin itself. Inside only 2 months of its activity, the JWST caught pictures that went against conventional comprehension, recommending that the universe might not have begun with the enormous detonation as recently suspected. This disclosure has sent shockwaves through laid-out specialists, provoking a reassessment of speculations that have been acknowledged for quite a long time. The speculation of the universe's beginning stage has been profoundly implanted in the aggregate creative mind of mankind. It has been shown in schools, referred to in mainstream society, and generally acknowledged as the authoritative clarification of how the universe started. By this hypothesis, all that we see today, from the littlest particles to the biggest worlds, started from a solitary point. Without a doubt, Georges Lemaitre, a Belgian minister and astrophysicist, first proposed this thought in 1927. Lemaitre's speculation was progressive, proposing that the universe was once compacted into an early-stage particle that detonated, prompting the development that proceeds right up to the present day. His work laid the preparation for what might turn into the theory of the universe's origin, a model likewise upheld by Edwin Hubble's perceptions of far-off systems getting away from us. Given the specific proof expected to approve Lemaitre's speculation, his revelation that the universe is as yet extending was a critical achievement throughout the entire existence of cosmology, laying out the enormous detonation speculation as the essential clarification for the universe's start. The hypothesis places that the universe began from an uncommonly hot and thick state and has been cooling and extending since, prompting the improvement of stars, worlds, and any remaining enormous designs. The story of the speculation of the universe's beginning stage portrays a universe that started in a very thick and hot state, loaded up with a tempestuous combination of subatomic particles, light, and energy. After some time, as the universe extended, it started to cool, permitting particles to join and shape iotas. These molecules in the long run bunched together, impacted by gravity, framing the principal stars and worlds. This course of astronomical development went on north of billions of years, prompting the mind-boggling and various universe we notice today. The early stars assumed a fundamental part in creating heavier components through atomic combination, which later turned into the structure blocks for planets, space rocks, and other heavenly items. Universes blended and blended, bringing about considerably bigger worlds and setting off the arrangement of new stars, dark openings, comets, and other interesting, inestimable peculiarities. This amazing story has been upheld by an overflow of observational proof, making the huge explosion speculation the most generally acknowledged clarification for the starting points of the universe. Notwithstanding, the new revelations from the James Webb Space Telescope have brought up critical issues about this account. Imagine a scenario where the huge explosion won't ever occur. This question difficulties the actual underpinnings of current cosmology and powers researchers to reevaluate all that they assumed they had some awareness of the universe's starting points. The new pictures caught by the JWST have tossed standard scientists into a condition of vulnerability. These photos seem to go against the hypothesis of how things came to be by showing cosmic systems that appear to have framed before the time the enormous detonation ought to have happened. As per the speculation of the universe's beginning stage, the most far-off worlds ought to show up as they did billions of years prior, when the universe was still in its outset. These universes ought to be somewhat little and not yet full-grown. Notwithstanding, the photos from the JWST propose, in any case, a portion of the notice systems show up enormous and brilliant, demonstrating that they might have shaped significantly sooner than the theory of the universe's origin would permit. In the event that these discoveries are affirmed, they would on a very basic level change how we might interpret the universe's set of experiences. The possibility that the universe started with a huge explosion has been a foundation of cosmology, yet these urgent perceptions recommend that our ongoing models might be deficient or even inaccurate. This has prompted extensive tension among specialists who have long upheld the huge explosion speculation. Cosmologist Richard Ellis, for instance, has communicated worry about the ramifications of these disclosures, taking note of that they could challenge the actual groundworks of cosmology. One of the most interesting parts of the James Webb Space Telescope's discoveries is the perception of an abnormally enormous number of smooth, more modest, and more seasoned systems. These systems appear to challenge the presumptions set by the hypothesis of grandiose development. On the off chance that the universe is to be sure extending as the hypothesis proposes, we would hope to see systems seeming more modest and fainter as we look further back in time. Notwithstanding, the JWST pictures show that these cosmic systems have all the earmarks of being bigger and surprisingly huge, bringing up issues about how we grasp the universe's development. This perception could recommend that we are seeing an optical deception brought about by the universe's development, or it could show something considerably more huge, that our ongoing speculations about the universe's extension are essentially imperfect. The obvious disparity in the size of far-off worlds saw by the JWST, contrasted with those seen by the Hubble Space Telescope, has touched off serious discussion among specialists. On the off chance that the universe isn't growing in the manner we at present accept, then, at that point, the cosmic systems saw by the JWST ought to be comparative in size to those nearer to us, and the redshift we notice which should be re-examined. This difficulties the theory of the universe's origin and opens up new roads of examination in regards to the real essence of the universe. The revelation of antiquated worlds by the James Webb Space Telescope has significant ramifications for how we grasp the universe. Assuming far-off worlds are to be sure more modest than we suspected, it could imply that our ongoing models of enormous development are fragmented or wrong. This disclosure has ignited a hurricane of hypothesis and discussion among laid-out specialists. A few researchers propose that the size error could feature varieties in the crucial laws of physical science when applied on a grandiose scale. This would suggest that the standards administering the universe could change relying upon the separation from the spectator or the states of the climate. Others suggest that there might be obscure elements or peculiarities impacting the presence of these universes that we still can't seem to understand. This surprising disclosure has lighted restored revenue in cosmology, with scientists anxiously looking for clarifications that could represent these astounding perceptions. The likelihood that how we might interpret the universe's extension and the development of worlds might be lacking or wrong has provoked a reassessment of long-held presumptions in cosmology. The James Webb Space Telescope mission, thusly, has given noteworthy pictures of a universe and constrained us to reconsider the actual idea of the actual universe. As cosmologists keep on breaking down the information from the JWST, they desire to uncover more signs that will assist us with unwinding the secrets of the universe and carry us nearer to grasping its actual substance. The James Webb Space Telescope addresses the apex of human accomplishment in the field of cosmology. Its central goal is to investigate the farthest reaches of the universe, giving phenomenal bits of knowledge into the starting points and advancement of worlds, stars, and planetary frameworks. The revelations made by the JWST have previously started to challenge our principal comprehension of the universe, provoking researchers to return to and reconsider existing speculations. The telescope's capacity to catch point-by-point pictures in the infrared range has opened up additional opportunities for analyzing the universe, uncovering peculiarities that were recently stowed away from view. As cosmologists keep on filtering through the information gathered by the JWST, they are finding increasingly more proof recommending that the universe might be undeniably more complicated and baffling than recently envisioned. The telescope's disclosures have lighted a re-established interest in cosmology, driving scientists to investigate new hypotheses and models that could make sense of the startling perceptions. While these disclosures might challenge long-held convictions, they additionally present an intriguing and open door to extend our insight and develop how we might interpret the universe. As the scholastic local area keeps on wrestling with these new disclosures, the James Webb Space Telescope will without a doubt assume a pivotal part in forming the fate of cosmology and our perception of the universe. The mission to comprehend the universe has reliably energized human interest and logical